It's the packet thrower! Welcome to the channel!
Hello, in this video I'm going to show you how to build a simple lab with VIRL. The reason for this is that the DevNet Associate covers a lot of different technologies that we need to know, such as firepower, WebEx, and practically all the routing and switching stuff. And in addition to that, VIRL itself is actually a topic. It wants you to be able to describe the use and roles of network simulation and test tools such as VIRL and Pirates. Not quite sure if you actually say Pirates, I never really say that word in a sentence, but Python ATS, how about that? So because of that, what I'd like to do is show you how to build a simple lab in VIRL, and we'll add some Linux hosts into it and get some automation tools on there, and it should be fun. Let's dive right into it. For starting out, we're just going to build a simple topology, but what I'm going to do is just set the management network. This is the IP address that VIRL will manage the host with there. If we leave this as not specified, it's going to use an internal IP that can't go anywhere. But if I want to use a shared flat network, the host will be able to get online there. So that means that our Linux host can get their updates and such without us doing any extra configuration, which sounds good to me. And then the other thing that I'll point out here is that the difference between VIRL and something like GNS3 is that VIRL is much more automation friendly, which is handy because, well, we can go ahead and add IP addresses on all the interfaces on our router topologies and such. The focus of this is more automation, and we don't want to spend too much time getting the basic connectivity going. So something like VIRL can help us focus on what we need by setting up the basic fabric for us. So I'm just going to pick a few options here. By default, it's going to be IP version 4. If I wanted to do version 6 or dual stack, I can let it know. And then we just tell it what the base subnet is for what it's going to allocate the IP address. And then we just let VIRL know what our base subnets are so that when we add interfaces, it can automatically assign. So I'm just going to randomly pick 10.66 and let's say 32.0 and let's say a 21 for our subnet there. For loopbacks, I like to use 255.0 and then I change it up every now and then so I don't get too comfortable, but this is what I'm using at the moment. And then the rest of it is a bit more than what we need. So things like IB version 6 and VRFs. And if we want, we can make sure that our routing is enabled. So I can just say yes, and we'll have it set up OSPF. This is going to automatically add all our interfaces into routing so that we can reach everything. But enough of that, let's start building our topology. So at the moment, what we're interested in is the CSR1000V. This is the iOS XE version of Cisco routers, and this is basically what everything going forward is going to be. This is most important for us for an automation perspective because they have things like your RESTconf and your fancy guest shell access that we'll be talking about. If you just want a generic Cisco router, you have the iOS-V, which is a lot more lightweight, and this is just the classic iOS. And then we have things like Layer 2 switches, we have XRVs for service provider stuff, and we have Nexus for our data center stuff. What we particularly care about in this video is the server, and what this is an Ubuntu host that we can configure as we need to for our automation stuff. I'm going to go ahead and add in a server, and I'm just going to call this server 01. Oop, can't type. There we go. And then the big thing for servers in VIRL is we need to give it a username, so I'm just going to call this the packet thrower. And then if you wanted to add your own SSH key, if you wanted to SSH directly into the box and you don't want to do password authentication, you just go ahead and paste that in here, which would look something like this there, just to paste my key. And then to save some time, I'm just going to copy this and paste this here. And this is just going to make it so that my username and stuff is already in there already. And then what we'll do is we can add in a couple routers. Call this R01 and R02. And why not, let's just add a couple other routers. We'll just say, actually we'll make this R02, R03. You can tell very clearly plan out these videos before I start making them. There we go. So we'll just go ahead and connect our network. Doesn't really matter how we do this there because the actual topology is not our focus. And then we'll go ahead and add in our servers. So at this point I can go ahead and generate our configuration. And if we look on a router, for example, and click on configuration here, we can do things like our host name and stuff, which isn't that impressive. But if we scroll down, we can see that it's allocated IP addresses in that range I picked up, the 1066.32. And it's basically just going to do a /30 for every new interface that we add here. So it's going to handle the IP address assignments for us there, so we don't need to actually worry about this topology. For the Linux host, VIRL's AutoNet kit uses something called CloudInit to generate the configuration. And we can customize this as we need to. So for example, if I wanted to make sure that the Linux host was up to date, I could just edit the configuration here and just say do a apt update like so. And then as it builds the server, it's going to go ahead and do that for me. If I wanted to, I could also go ahead and have it create files or whatnot, which is useful for more advanced things, and we can also adjust the routing. But I'm happy with that, so I'm just going to go ahead and go start. And it's going to build our topology for us there. Okay, so that's built, so I can go ahead and get into the devices by selecting them all and then just going console. And I set this up to open up my secure CRT. The tabs always get a little bit out of order, so I'm just going to clean this up. There we go. So we can see that our routers are built, and we can see what we have our IP addresses as we expect. And if we check, we should see a bunch of OSPF routes, which we do. So we can see the various loop access created. And then on the Linux host, if I log in with the packet thrower and password Cisco, there we can see that we have a Ubuntu 16.04 host. We can see that the 66 address is being provisioned, and also I have the flat interface, which is the external, so I should be able to get online if I ping, and I can. And DNS should work too, which it does. There, just clean up the screen a bit. So now what we can do is we can install some software. Because I already had the apt cache updated, I can just go ahead and go apt install. I'm just going to say yes to the prompts. And then we're going to install git so I can get some code from the repositories just for a few. First up, I'm going to install git. This is always handy for any kind of developer course there because this is going to store our code in repositories. I'll be talking this in the next video or two. And then because Python 2 is effectively dead as of January, we're going to be using Python 3 for this box, and we want pip so that we can install some Python packages like Ansible. Go ahead and install that, and because this is online, it's going to go ahead and download everything. And now I can go ahead and pull down a random repository, so I'm just going to go git clone. We'll be talking about what this does in more detail later on. And I just want to point out that because I have a longer string here, it's starting to wrap around. And then as I type more, it's replacing the cursor. So to get around that, what you can do is use stty columns and then set it to a high number. And now if I type git clone and then that URL again, the line doesn't wrap anymore there because I set the columns in the T2Y to be a higher number. So because of my repositories are private, again, we'll be talking about that soon, I'm just going to sign in. And I happen to clone one of the info block scripts I was working on. So if we look at, we can see that I was throwing together a script for allocating IP addresses from info blocks, but we don't really need to care about that. The next thing we might want is, now that our main software is installed, we want to focus on the Python side of things. So what I'm going to do is just go Python pip3 install pip upgrade. And what this is going to do is just going to go ahead and update the pip package to the latest version. So we can see that I went from 8, which is quite old, to 20, which is much newer. And now what we can do is I can do sudo pip3. I can get fancy with installing a different users, so whatnot. I'm not going to bother here, so I'm just going to say pip3 install, and we're just going to say Ansible. We can also install other packages that we want, like say no-near, which is kind of an Ansible replacement for doing playbooks inside code. And then if we can do things like Ipython, which is a great shell. Generally speaking, it's always better to install things with pip rather than with the package manager, because pip will have the latest versions, because it takes a while for Ubuntu, or because it takes a while for companies like Ubuntu to certify the package, whereas pip is much faster. Okay, so pip has installed those packages, installed all the prerequisites. So to try this out, I can actually just go type Ansible. And I'm not quite ready to talk about Ansible yet. We'll be doing that in a separate video, but this is it. It's ready to go, and it's at the latest version at the time of recording. I will show you the Ipython shell, if I can type that is. Ipython, there we go. And this is different from the regular Python console for typing commands because it offers more interactive help. So for example, if I type import and type tab, it's going to start letting me do autocomplete stuff. So to do a random example, let's just do import IP address. And then I can do something like list IP address. And if I want to see what I can do, I can just hit tab and it'll tell us the different things. We'll say IP network. And then I'll pick a random IP network, which is say 11.22.64/28. And then I could do something like host, like so. The IP address module handles IP address operations, as you might have guessed, and this particular code is just showing us what hosts are in this subnet. So this could be handy if you want to do some subnetting related programming. But the point of this is that the Ipython is a handy shell if you want to do some testing with code. At this point, we have a simple lab with an Ubuntu server. So if I was to click on one of our routers here, like say this guy, and grab an IP address, this server can reach that IP because there's no routing restrictions. And if I wanted to, I could SSH in. So I could use this host as my jump box for doing all my scripting stuff. And then if I wanted to move code back and forth, I could just use Git to transfer the code and everything works great. The only real downside to this is that the host, at least at the time of recording, is 1604, so it is getting a little bit older. And it doesn't have a ton of free space there if you're going to be installing a lot of different options, like you want to start getting into Docker. But it's handy for a quick and easy lab where you just want to try Ansible against a couple routers and you don't want to worry about doing external connectivity. If you want to, you can take a snapshot on VIRL there to protect the image there so you could use it in future things. So what we'll do is we'll end the video here, and then in the next one I'll show you how to make your own custom images in VIRL, and we'll have some fun with some of the tool sets. Should be a good time. I'll see you there.